Okay, welcome back. So in this topic, we're going to talk about another important aspect of learning mathematics. Um, it's about the order of operations. Now, many of you might experience this or maybe haven't really got into this topic a whole lot, but I would like us to really get what the order of operations is in its theory base. So I want you first, when you write this down as a topic, I would like you to really pay attention to these symbols here. Now, these symbols here are a way of what we call a different way of grouping. When I say grouping, it's kind of like grouping the same things together. So like M&Ms with Skittles, or pink with blue. And you just want to, they're just grouping symbols. And sometimes on one problem, you can see all three of these. And it's not just to mess you up, it's to keep you organized. And that's part of the math foundation, or the math thinking is a systematic way of thinking. You're trying to make it simpler for you to understand, um, how are you grouping, or how are you organizing your facts to find a proper solution. So have these down, or have these pretty much in the back of your head somewhere. Okay, so you got parentheses, you got brackets. They look like a square that's been taken apart. And then you have what we call braces. Okay, so put those away. So let's go. So the first thing to do is, the order of operations tells us the order to solve steps in expressions with more than one operation. Now, if you don't know what an operation is, it's pretty much a multiplication, addition, subtraction, and division. Those are what we call the operations. So this order of operations, see how the S is there, and it could involve all four of these. Sometimes it can just be one. Sometimes it could be two. And you kind of get the point from there. So let's keep going. Now let's try some examples first before we really dive into this. So first thing is we have these two here. Okay, these two here, these two examples. You're gonna be like, well, they are the same example. Yes, they are, but you have to go into a process, or you have to have a procedure in order to get the right answer, believe it or not. So this is 3 plus 5. Zoom in a little bit for you. This is 3 plus 5 minus 6 divided by 2. So in the order of operations, we can go ahead and we can do 8 first. Well, what if I add these two first? I have 8. And then I'm going to bring the rest of these down. So all I did is 3 plus 5, I got 8, bring these two down. Okay, but on this one, I did the division first. 6 divided by 2 is 3. Okay, so keep going. And then you get 8 minus 6 was 2 divided by 2, which is going to be 1, right? Well, look what happens here. You have 3 plus 5 minus 3. Well, 3 plus 5 is 8 minus 3. Well, look what they both equal. This one's 5. This one's 1. Well, obviously, they're not equal. 1 does not equal 5. So it really does matter what one goes for. I mean, what procedure is the correct one? And so to answer this, that's why I gave you the same problem but different way of doing it. We have to have a process, and this is what our calculators and our math, how it works in the real world is. So the problem is, so what's the problem? We can say that in order to make this work the correct way, let's use PEMDAS. Now, some of you might not have ever heard of PEMDAS. Some of you will be like, well, I know what PEMDAS is. That's no problem. Okay, well, then you're going to tell me. So PEMDAS stands for these 6 operations. Yes, I want you to know these because this is really the foundation of math. This is the process of actually having our math problems work effectively. And so let's go through this. So P in PEM is that parentheses. It's that grouping symbol that we talked about. E stands for like an exponent. Exponent means something that's raised. So I can say I have x times x, which is x squared. Multiplication, which is your M, well, multiplication, or many other students might say, well, that's actually can just be a dot, right? Yes, it can mean the same thing. Then you have division. Okay, now once you get down to the division, it really doesn't matter what goes first. So these two here, it really does not matter. Pretty much what goes first. So some students like to do, well, I see a subtraction first, I do subtraction. I see addition first, I do addition. These two don't really matter, but these 4 do. So let's make a note. So do matter and doesn't matter. And we're going to see many examples of this. Okay. And another way you can remember this, we like acronyms, but we also like little sayings involved. And if some of you know the saying to this, it's called, please excuse my dear Aunt Sally. And there's other ways of remembering this, but this is how I was taught. And this is what I hear a lot. So, and other teachers use the same language. So I just want to kind of keep on the same. Okay, so we got PEMDAS down. So let's do some examples of this. Okay. So here we go. This first example is not too bad. So here we go. So in order to do this, let me zoom up a little bit here. We want to, so what I would like you to do is always have, PEMDAS pretty much in your heads when you do this, PEMDAS. So here we go. First thing, I don't see parentheses. I don't see any of those parentheses around. Okay, take it out. Do you see anything that has like a squared or a 3 to the raised? Be like, well, I don't see any of that here. Well, take it out. Do you see any multiplications? Well, let's see. Oh, there's one right there. Okay, so that's what we're going to do first. So what I would like you to do is write down what you don't use. So 3, then you're going to go 6 times 4. Well, 6 times 4 is 24. You got to know your multiplication table, by the way. Divide it by 2. Okay. And I'm hoping that you understand that I'm going from left to right. From left to right. So multiplication's gone. What about the D for division? Oh, I see division. I see division. So that's why I bring everything down to make it so clear so you're not leaving anything out. So you can go too fast on this and you can get lazy and you can skip things and leave things out and then you'd be like, uh-oh, where did that go? So be very careful. Write things down. Don't be lazy. Take initiative for this. So we have division. So I'm gonna write down the 3 because I didn't use it. 24 divided by 2. So I had to think about 20 divided by 2. Half of 24 is 12. Good. Now, so that is gone. So division's gone. What's next? Well, now you have the addition and subtraction. Well, what operation do you have here? You have addition. So that's your next part. So let's see. 3 plus 12 is 15. So 15 is going to be your answer. Wait a second. There's no subtraction. Do we have to use it? No. It's not there. So technically, you can just go ahead and get rid of it. So this is your number. I will show you later when you use a calculator. When you use a like a calculator, you can put in the same thing and get the answer. But that's cheapening it out. You need to understand the process. I don't care about what this gives you. I care about what you're thinking involved. So this problem here, if you put that in, you should get 15 into the calculator. Now, let's try that later. So let's do some more. Okay, so let's try this one on 2. So you might want to go PEMDAS always to help you out for a little bit. It's good to write this down all the time because you need to know what you're doing first. Okay, so I don't see any parentheses, so no parentheses. What about exponents? Or E for exponents? Well, there's a 4 to the 2 power. Well, there's your exponent. So you're going to do that first. So you're going to go 3 times 6. What is minus 4 times minus 4? This is minus 4 times minus 4. And what is that going to be? Well, 3 times 6 times, no, it's not times because what's negative times a negative? That's a positive, right? So that's a positive. And that's negative times a negative is a positive. 4 times 4 is 16. So now you have this goes to 16. Okay, so exponents are gone. Do I have any multiplication? And the answer is yes. 3 times 6 is 18. So you're going to go 18 and bring down the 16. See how I'm always bringing down what I have because if you don't do that, it ends out to be, you're going to miss something. So, do I have any division? Well, no. Do I have any addition? Yep. Okay, so you're going to go 18 plus 16. I'm just making sure 34 is your answer and no subtraction. So there is going to be your answer. Okay. So let's keep going. So this one here, this one's not too bad. This one looks like a lot of work. And you're like, well, yeah, there's a lot of work. So, but really all you have to remember is your PEMDAS. And PEMDAS is a way of organizing your thoughts and organizing the process here. Okay, so first thing is first. Do I have parentheses? This time I do. So 3 times whatever this is. So 3 times whatever this is divided by 2. So let's see. 6 minus 4 is 2. Okay. So parentheses is gone. Now you'd be like, well, parentheses is not gone. It's why did I still write it there? It doesn't matter. Like I said, it's a grouping thing. So for example, I can go 3 times 2 divided by 2. If you prefer this way, that's fine. Okay, you prefer that way. That's okay. All right. Do I have any exponents? Well, nope, no exponents. Do I have any multiplication? Yes, I do. I have multiplication. So 3 times 2 is going to be 6 divided by 2. You see how I'm keeping down the same thing, keeping my step organized. So multiplication is gone. Do I have any division? Yep, this is it. Okay, so 6 divided by 3. If this confuses you, another way you can write it is 6 divided by 2. That's another way of writing it, if this bothers you. So let's do, that's going to be 3, right? There's no addition and subtraction, so you don't need to use the operations. So what I say, you don't have to use everything in here because we only got division to be our last operation, and addition and subtraction, they don't really matter in this case. Okay, keep on going. The more you do, the more you get. The more you get, hope you get better at this. Okay. Number 4, you might want to stop, and you may stop this video, and you can probably do it yourself just to see. So anytime you want to do that before I do it, go for it. So PEMDAS. Okay. Will I do this all the time? No. This is just for an introduction to get you used to this this process, and then after a while, don't even need to write it anymore. All right. This is a little different, but not too bad. Okay, parentheses. No parentheses at all. Okay, so parentheses is gone. Do I have any of those exponents? Any of those x squares or 3s? No. Do I have any multiplications? Yes, I do. Okay, so you have 6 times 2. 6 times 2 is going to be 12 minus 1 divided by 9 plus 2. So multiplication is gone. Do I have any division? I do have a division part. Okay. This is going to be an exception. So we're going to do an exception here. This is an exception. And the reason this is an exception is because this process sometimes needs to be kind of simplified first. So it needs to be a little bit simplified. What I mean by simplified is that you're going to have to kind of not follow this 100%. There's always exceptions, but in this part here, this will work. You're not doing any multiplication, you're not doing any division yet. All you're going to do is just get something a little bit more simpler. So, for example, on the top, it has 12 minus 1. Well, what is 12 minus 1? Well, you're going to be like, well, it's 11. Okay, cool. Divide it by, well, that's the top. What's 9 plus 2? Well, let's see, 9 plus 2 is going to be 11, right? Okay. So all you did, you made an exception of the rule. And all you're doing is you're simplifying. You're getting some numbers a little bit more simpler, so when you divide, you can make an answer out of it. Well, what's 11 divided by 11? Well, that's just one big 1. So sometimes you're going to have to make an exception, and this is hopefully going to be obvious for you. Okay? Like I said, you have to have practice on this. You have to keep going on these. So, keep going. So, this is, my handwriting is kind of not 100%, but that's okay. So this right here is supposed to be a bracket. Okay, so hopefully this will be not too bad for you. So I'll use a different color as well. So you can stop the video and do this one before me, or it's really your choice. It doesn't matter to me. All right, so here we go. 25 minus this big old bracket. So you have this big old bracket with all that information. Okay. So in PEMDAS, it says you do parentheses first. So 25 minus bracket 2 times, what's 3 plus 7? Well, 3 plus 7 is 10. Close bracket. So really all you did is you added inside the parentheses and you got 10. And look how you didn't use the bracket yet. You didn't use the bracket yet because that's the next step. That's kind of like two parentheses into it. So now you're going to go 25 minus bracket, and like I said, sometimes you're going to make an exception of the rule, but as long as you keep the flow, you're fine. So 2 times 10. 2 times 10 is 20. Okay. Well, now what? Well, 25 minus, you can think of this as minus 20 because really this minus is going to go with that 20. This minus goes with that 20. And you have 25 minus 20, which is 5. Now you'd be like, well, I don't understand this still. Okay. A side note from this, a side note. So a side note, what is negative 1 times 20? So question mark, what is negative 1 times 20? Well, that's negative 20. Well, there you go. Really, this is just a negative this. This just means negative, really. And that's kind of what parentheses do. They're almost like a parentheses or a bracket is almost like a multiplication. It's almost like a multiplication operation. It's almost like a multiplication. In this aspect, you can consider as a negative times a positive. Okay, but like I said, you got to do more of these, and that's part of it. You have to do hundreds of these. You can't just do 5 and say, hey, you know what, I'm an expert now. Okay. No, don't do that to yourself. All right. Number 6. Now, I kind of did this one for you to kind of see what you get on it. So I would like you to kind of maybe see what I did, and maybe you can get the same answer. I mean, try this. Don't skip on yourself. So I have 8 minus 3 plus 2 times 4 squared times 2 minus 1 plus 6. So here I go, PEMDAS. Well, I do parentheses first, right? Okay, so 8 minus 3 is 5. Okay, cool. Plus, well, parentheses, 2 times 4. Well, I know that's 8. 8 squared times 2. Well, I can do parentheses here. 1 plus 6 is 7, but the minus goes with the 7. So right now I'm here. Okay, PEMDAS. Well, now the 5 goes down. 8 times 8 is 64, because that's the exponents, times 2 minus 7. So the only operation I did in this line here is do 64. Okay, here we go. 5 plus, okay, so, sorry, repeat, back up. Multiplication, so the 5 goes down. 64 times 2 is 128. So I went 64 times 2 because that's your multiplication, and bring that down. Now I have 5 plus 128 minus 7. which gives me to 126. So I hopefully that kind of worked at this a little bit. Okay, so remember that PEMDAS. Okay. So there's a lot on this topic because this topic's pretty big. So let's do some more. The more that you do, the better you're going to get. All right. So this one here. So we have minus 3 times 4 squared times 5. So here we go. Minus, well, 3 times 4 is 12. 12 squared times 5. Okay. Do you see how I'm not using really the PEMDAS writing down anymore? I'm trying to get that out of my head, or have it in my head, sorry, and I'm trying to follow it with what I know. So here we go. So parentheses, well, parentheses are done. Exponents, there's an exponent here, something that's raised. So you're going to go minus times 12 times 12. We got to know your multiplication tables. That's 144 times 5. So now that's what you have. So what's next? Well, let me ask you something. Isn't this really a multiplication, to tell you the truth? Isn't this really a multiplication right here? Well, you're gonna be like, well, that doesn't make sense. Well, isn't this negative 144 times 5? Isn't that correct? Isn't that negative 144 times 5? And that should be negative 720. Okay. Now, what I want to do is show you on a calculator if this is the correct answer. So this is a TI. This is something you can buy at pretty much any place you can. So I'm going to put the same thing in here. So make sure I have this correct. And if you can, hope you can see that. So I have minus parentheses 3 times 4 close parentheses. Okay. And then I'm going to go the exponent times 5. Okay, let's see if we get it. Oh, there you go. And you will get used to putting this in a calculator a little later. I don't want you to use a calculator on this because I kind of want you to see the keys to it. So then you get 720. So negative 720, negative 720. Okay. Next one. This is something that you should have in recent years, but I don't know your history too much. But really, it should be in your history here. So this is a volume of a sphere, or not sphere, a cylinder, so like a Coke can, or a can of beans, or a can of olives, I don't know. And you have pi r squared h. And hope you know a little bit about pi, but that's okay if you don't. But pi is, we're going to call it 3. Long time ago, back in the Greek area, it was just 3 for a while. And then it got a little bit more into it, but that's another later. That's a later lecture. Okay, pi is just 3. So we're letting pi be 3. We're letting the radius of the can, the r, be 2. And we're letting the height be 5. I want you to find the value of 5. Well, how would you do v? How would you do that? Well, we're going to take all these informations and we're going to plug them into this. So we're going to go v equals 3 times 2 squared times, what was the h for this one? Wasn't it 5? Yep. 5. So all I did is plug in these three numbers in for my findings here. And this is what I got in return. Well, if you know the order of operations, you can go ahead and do this. Without a calculator, you can go ahead and do this. So V is equal. Well, you can just ignore V for a little bit and say, okay, what do I do first? Well, I have an exponent. So remember PEMDAS. Okay, PEMDAS says I do exponents first. So go 3 times, well, 2 times 2 is 4 times 5. Good. Now, multiplication is the next and final thing, but you have 3 things to multiply. I hope that you can go ahead and do this. So you can go from left to right. Doesn't matter how you multiply this, really. You still get the same answer. That's a certain rule of math. If you have all multiplication, doesn't matter what you multiply. So 3 times 4. So 3 times 4 is, you can do this any way you want. So 3 times 4 is 12 and times 5. So now you should have what? 3 times 5 is 12 times 5. That's 12 times 5 is 60. So V is 60. There you go. Now I did put inches for all these, for inches. So if you want to, I don't want to go off topic here, but maybe some of you might recall this is inches cubed. I don't really want you to focus totally on that. I just want you to understand the order of operations because that's our topic. This is for a later date, but something that should have been introduced to you recently. Okay. Well, couple more. Let's say, for example, that maybe you want to do money. Well, what's this do? What's this do with real life? Well, you do this with money all the time. Exactly. So let's say here you go, and let's say you have 2 times $15 minus 7. So let's say you have something like this. So somebody gave you $15 and they gave you and they doubled your money. And they doubled your money. Well, that's nice. Well, that's what? That's gonna be $30, right? Then you go buy something at the store. So it costs $7. Well, how much do you have left? $30 minus 7. Do the math. $23 left. You do this every time. You can, what if I did this? 15 minus 7 and then times that by 2. Well, that wouldn't work. That wouldn't work because what is 15 minus 2? 15 minus 7 is 8. Well, 15 minus 7 is 8. Well, what's 8 times 2? Well, times 2 is 16. Interesting. So if I do this another way, I have 16 instead. Well, that's not correct. So I just want you to understand there's a process to this. And some students, they are even people, they don't really want to know the order of operations, but they think it's easy. When you do it with money, but really it's not. Okay. I think I have 2 more. Okay. This is a hard one. So when I say a hard one, it might be pretty easy, pretty understandable, but it's still a lot of thinking process. So number 10. So let's see here. This is 3 plus absolute values. If you don't know what these are, that's okay. Plus 2 squared divided by 6 minus 3. So let's go ahead and do this. So PEMDAS. So what goes first? So 3 plus, well, what is 4 minus 3? 4 minus 3 is 1. Okay. Plus 2 squared divided by 6 minus 3. If you didn't learn about the absolute values, right now, think of them as a parenthesis, but for those students that remember what an absolute value is, what is the absolute value of a minus 3? It's just 3. What's the absolute value of just 3? Just 3. Okay, this is just something for later. These are called absolute values, and that's kind of what this is. So you can have these in here, but don't worry about this if you haven't got this far. But if you have, cool. So keep going. Let's see, PEMDAS. So we have 3 plus 1 plus 4 over 6 minus 3. So, okay, well, what's next? Well, PEMDAS. Well, you might have to add first. Remember that's exception of the rule. So 3 plus 1 is 4. Plus 4 is, let's see, is that 8? 4 plus 4 is 8. 6 minus 3, let's see, 6 minus 3 is 3. Okay, there you go. Now, some of your teachers might say, I want this to be reduced. I want this to be reduced. And I'm going to say probably the same thing. And what I mean by reduced, this is called an improper fraction. So this is called an improper fraction. And that's kind of what you need to watch out for. So I hope that you know how to do this here. So how many 3's go into 8? Let's see, 3 goes into 8 2 times, right? 2 times. 3 goes into 8 2 times, because 2 times 6, or 2 times 3, 3 times 2 is 6. Well, how many more to get to 8? 2. So this is 2/3. So really, that's how you do that. And you'd be like, well, I don't know how you did this. Well, that's fraction based. That's just how many 3's go into 8? 2 wholes. Well, how many you have left over to get to 8? Well, 3 times 2 is 6, 7, 8. You have 2 more, and you have the same denominator. Okay. One more. Let's see if you got this. So this has two brackets, or one bracket in other parentheses. So kind of like something that we've been doing. So here we go. PEMDAS. So 3 bracket 4 plus 2 parentheses. Okay, parentheses first. So 10 minus 1 is 9, parenthesis, bracket. See how I didn't change anything? Well, when I say that, I'm changing the stuff that I know. So this is going to be 3 bracket 4 plus 2 times 9, which is 18, close bracket. See how I'm keeping everything organized? I'm hoping that you're doing this on your notes. Okay. So now you're going to be like, okay, so 4 plus 18, which is, I think, 22. So 22, close bracket. Okay. Now, times that by 3, you should have, what, 66? So that should be 3 times 22 is 66, and that's your answer. Okay, so I want you to understand that this is a lot of thinking process. When I say thinking process, it's the order that you do it. So, a few things I'm going to attach on your notes, or for this assignment, is that first off, you have this as a little bit of a helper. So PEMDAS and some work. And I might give you this as well. This is something I got from the internet. Please excuse my dear Aunt Sally. So this will really, this is helping you for your notes a little bit. Okay, so hopefully that this made sense. If not, you're gonna have to probably watch this again. But if you've been taking notes, you can just practice the ones and just recheck them. So I'm hoping that you're trying this. So I We'll see you on the next video. Good luck, everybody.